welcome back again. We'll be looking at another vectors question. So in the first one, it had shape, and you had to calculate the vectors based on the shape. Now, these are two other approaches that vectors may be given in. So this is one where you're given the vectors as numeric squares in the xy column, and they're also based positioning or based on position of them on a graph sheet or so forth. Now this particular one says given vector OP equal 3, 4, PQ equal -1, 2, and RS equal 1, 3. Determine the vector OQ. So they are saying that if you should move from O to Q, because these arrows tell you which direction you're going and the letters tell you what you're starting on and which you are ending on. So the first says you're starting there, the latter says you're ending there. Now in these cases there are two approaches. Now for example this question, it tells you OQ, so it means you're starting on O, you should end at Q. So you're going to look at the vector values you get and tell which of these three starts on the coordinate O. So in this case it would be OP plus, and then which of them ends with Q. So that would be PQ. So it's going to be O to P plus P to Q. Now normally, once you're dealing with vectors of this nature, two of the letters must be the same because you're going to be starting on one point to go to a point, and then you're moving from that particular point to the end product. So you're moving from O to P, then you move from P to go to Q. Now if it was a case where you're starting on a letter, so say this was Q to O, that's what was there. It means that you would have to be searching for which of the two vectors has a Q in it, and then whatever Q is paired with, it must be paired with the letter O. So you look, okay, PQ, so you have a Q here, it's paired with P, so then you search for the P now, P and it's paired with O. So you'd be searching through to see which letter is paired until you reach at where the other point. So in this one, OP is equal to 3, 4 plus PQ is equal to -1, 2. So this is equal to 3 plus -1 would be 2, and 4 plus 2 would be 6. And that would be the answer. Now there are certain cases where you have to put a minus here, or rather you will still keep a plus here, but then the values in the vectors change to their opposite. So if it was a case where this was flipped around, so because you are going in the opposite direction of what these original vectors are going, it would make it become negative. So you have to pay attention to the arrows. Once you're going in the same direction as the arrow, you keep it as the same. If you're going in the opposite direction of the arrow, it means you have to flip the signs of them. So like here, P to Q, it's -1, 2. But if it was a case where you had something to say, Q, P, it would have to be flipped around. So this would have to change to a +1, and then this would have to be changed to a -2. So you have to pay close attention to where the arrows are pointing, that you can keep what needs to be kept and change what needs to be changed. So now here this second question now says, show that OQ is parallel to RS, giving a reason for your answer. Now from the other video on vector, it would have made mention of collinear. So collinear deals with a point being a scale factor of each other, and then they share a similar point. So for example here, O to P, P to Q, because they would be sharing similar points, that would need to be there for a collinear vector. So in the example before, I think it was LM and R that needs to be proven to be collinear. So because LM was there and then you have MR, so the M's are similar between both vectors, and then they were scalar, so that makes them collinear. Here now for a parallel vector, what needs to happen is that they need to be a scale factor of each other, but they do not necessarily need to share a point. Well, they more so don't need to share a point, because once they share a point, it's collinear. But when they don't share a point, it is just parallel once they are scale factors of each other. And so this now says, show that OQ So we have OQ here already. So OQ is 2, 6. Must be parallel to QRS. So they must be parallel to RS. And RS is equal to 1, 3. So what you need to do is to now figure out, are these two things scalar factors or scalar multiple of each other? So in proving, it should say that OQ is a scalar. So let's put back the K here that represents the scalar. So OQ must be a scalar of what RS is. So let's look at RS. So RS is 1, 2. What could you possibly do to 1, 3 in order to get 2, 6? So you can simply divide. So 2 divided by, so this divides by this, 1 equal 2. And then let's take the 6 divided by 3. That's also equal to 2. Therefore, because they have a common factor or a common multiple of 2, it therefore means that OQ is equal to 2 RS. So if RS is 1, 3, and you multiply that by the 2, you are definitely going to get the 2 ones, 2, 2, 3, 6. You are going to get that. So because that is proven and they don't share any common point, it is parallel. So you'll be able to say that this is parallel. So show that. So this is the show that. And then for this part now, given the reason for your answer, you can say RS is half the length of OQ, or you can say OQ is twice the length of RS. Thus, and they share no common point, thus they are parallel. And that's it. Now in this case, for this last form of vectors now, it now says you get this graph, and then they say write in column form x of x and y, O to A. So you come at O and you go to A. So once O is here, meaning the O is the origin, the point of origin 0, 0. And you are moving from the origin to any point on the graph, all you basically need to do is write the coordinates of the point in a vector form. So in this case, what's the coordinate of A? Because it's moving from O, that's -1 on the x and 3 on the y. So all you need to do, so -1 on the x, 3 on the y. And that's the answer. In this case now, for O to B, let me put the arrow. O to B, it's starting at the origin and you're going to B. So B on the x is 5. And B on the y would be equal to 1. So you're writing 5, 1, and that's it. Now this last part there says what is B to A. So there is two ways you can work it. You can work it from the graph, or you can work it using these values. So let's work it from the graph first, which is easier. So you are starting at 5 and you're coming to A. So you're going to be going step by step. So 1, 2, 3, 4, 5, and you land at 6 to give you that value. So the top part would be 6, and because you're coming left, you put a negative there. And then now you are going from B to A, so you're going upwards now. So that match, since this is at 1, this is at 3, so you go 1 to match it at 2, 2 to match it at 3. So you went 2 up. So that's the answer, -6, 2, if you are going from the graph. If you don't have the graph to work with, but you have these values, all you need to do is basically subtract. So you can say, alright, because you're starting with B, O, B, and you're moving from B to A, so you look at this one. This starts with B, so you put, and it's going in the opposite direction, so it becomes -5, -1, and then OA, you're still going, because you reach back at O, then now you're going up. So let's write this as BA would be same BO plus OA. So BO would be -5, -1 plus OA would be negative 1, positive 3. And you add the negative 5 plus negative 1 equals negative 6. Negative 1 plus 3 gives you positive 2. And you see the answers are the same. And the final way for you to do so as well, whenever you are given a vector of this sort, and they are telling you to move from one vector, and you have these two. So this ends with A, this ends with B, and this is telling you to start going in the reverse order. All you need to do is say, alright, you write the vector that you are ending with. So that's going to be A, which is negative 1, 3. And then you will put the second, which put a subtraction sign, minus, so this is the one that you end with minus the one that you start with. So minus 5, 1. And you subtract negative 1 minus 5, that gives you negative 6 there, and 3 minus 1 to give you 2. So all three approaches will give you the same thing. So if you want to count it from the graph, that gives you 1. If you want to switch the vectors around to match the coordinate points that you need, that will also. And if you want to take them as they are, put your ending point first, subtract your starting point, it will also give you the answer. So these three approaches will entail or cover what vectors deals with. So I hope these would have explained or clarified misconceptions on vectors and allow you to proceed or to get better at it. So thanks for watching, and tune in again when I explain other mathematical concepts.